We're looking at some special cases, and this will just make it easier once we realize the pattern for these special cases to just multiply quicker. Okay, so we're going to do the same thing that we've done before where we make the box. I like the box. You guys can do foiling if you want. Those ways are fine as well. I like the box. So I've got x here, positive 5 down here, x on the top, negative 5 on the top. All right, we go x times x, we get x squared. X times 5 gives me 5x. X times negative 5 gives me negative 5x. Negative 5 times 5 gives me a negative 25. Now, when we add our like terms together, there's no like term for x squared, so that goes first. Then 5x minus 5x is 0, so that disappears. So we get negative 25. This means this pattern that I'm seeing here is we just square the first term, square the second term, and put a negative in between. So instead of doing this box each time, we can do this. Number 2, we've got n minus 1 and n plus 1. This is just going to give me n squared minus 1 times 1 is 1. Okay, it's a little more obvious with like number 4. X times x is x squared. 3 times 3 is 9, and we're going to put a negative 9 there. So that's just the pattern. When you have two polynomials where they have the same first and last term, but different sign in between. For number 3, we're going to see a pattern when it is a letter minus a number and it's squared. Okay, and see what the pattern is here. So I'm going to do this in red. Here, we'll do a different color. So we've got right here p negative 1, p negative 1. P times p is p squared. We get negative 1p. We get negative 1p. Negative 1 times negative 1 is a positive 1. So when we combine like terms, we get p squared minus 2p plus 1. So now we know when this pattern is going to be if we have p minus 1 squared. So if we have some letter minus some number squared, we're going to take the first number squared minus a 2 in front of the letter plus the last thing squared. So like number 5 could show you right here, you're going to end up with x squared minus, we've got 2p here. So instead of 4x, we're going to have 8x. And negative 4 times negative 4 is positive 16. That's all that's doing for us. Okay. So we'll do one more like that for number 8. We're just going to get n squared. Negative 5 plus negative 5 is negative 10n. And then negative 5 times negative 5 is plus 25. Okay, how does this change if I do the same thing, but I have a plus sign in the middle? We're going to see what happens right here. We've got n3 and n3. N times n is n squared. We've got 3n, 3n, 3 times 3 is 9. So we end up with n squared plus 6n plus 9. So only the differences for when it's negative for when it's positive is that that second, first and second term are separated by a plus sign instead of a minus sign. So that is special. cases.